When a new AI model drops, the question that matters for most teams is not the leaderboard score. It is whether your stack can run it reliably, what it costs at your traffic scale, and which shortcuts will break in production. Today we connect that headline to the engineering trade-offs behind the hype. You might assume modern search algorithms are robust against manipulation because they understand context better than old keyword bots ever did. But when drug sites hijacked Spotify's search ranking through thousands of fake podcasts, it wasn't a security bug or a hack. It was an exploit of your own algorithm's logic. This incident reveals a deeper architectural failure in how we build trustless recommendation engines. We optimized our systems for engagement and natural language relevance while assuming authenticity would follow naturally. Instead, bad actors reverse-engineered these heuristics using synthetic audio to flood the index. This is not just about annoying podcasts. It represents a phenomenon researchers call retrieval collapse. It occurs when high-volume generative content creates a homogenized ecosystem that looks accurate but has zero source diversity, effectively poisoning the data for future models and making your system blind to its own degradation. To understand why this happened, we must look at the shift in how search engines operate. We moved from static retrieval methods like BM25, which relied on matching specific keywords, to systems driven by generative synthesis and large language model-based ranking. This new architecture rewards plausibility over provenance. When a bad actor creates thousands of fake podcast episodes using synthetic audio and SEO-optimized metadata, the algorithm treats them as legitimate because they match relevance signals perfectly. The system does not verify who created the content, or if it exists in reality. It only measures how well it fits the user's query based on semantic similarity. In controlled tests simulating this exact scenario, we see that traditional keyword-based systems failed to filter roughly 19% of harmful synthetic content when exposed to these adversarial attacks. While newer large language model rankers showed better suppression capabilities by understanding context more deeply, the underlying vulnerability remains unchanged. If an algorithm cannot distinguish between high-quality human text and high-quality AI-generated spam, it will index both equally. The system sees a perfect match for the search query and assumes that is all there is to know. It does not realize it has been tricked because the output looks identical to what a genuine source would produce. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This leads us into the theoretical framework of retrieval collapse. Research from Navercorp defines this failure mode explicitly as a two-stage process. First, synthetic data dominates the index, creating a healthy but fake ecosystem where high-quality AI-generated content floods the results. Second, adversarial actors inject malicious or low-quality material that standard filters miss because it is buried in layers of plausible noise. In scenarios with 67% pool contamination by artificial intelligence-generated content, search results showed over 80% exposure to synthetic sources while maintaining stable accuracy metrics. This means the system thinks it is working perfectly even as the source diversity vanishes completely. The stakes become clear when we consider how quickly a clean index becomes toxic. We are seeing evidence that in scenarios where contamination reaches 67%, the search results maintain high relevance scores despite being overwhelmingly synthetic. The algorithm continues to function within its defined parameters of accuracy and engagement without triggering any alarms. This creates a feedback loop where bad actors have even more leverage because they can rely on the system's confidence score rather than their own content quality. However, there is another layer to this engineering flaw that often gets overlooked: the human element. A study on AI prediction found that over 40% of users treat AI predictions as infallible authority. This behavioral shift means developers and product managers are less likely to question algorithmic outputs, allowing these systemic vulnerabilities to persist longer before being patched. When we stop verifying sources ourselves because we trust the machine too much, bad actors gain a massive advantage. They do not need to hack the system, they only need to feed it enough of what it wants to see. The data on human behavior reinforces this risk. In studies involving over 1,300 participants, those influenced by AI predictions showed an earnings reduction ranging from 10.7% to 42.9% compared to their baseline performance. Furthermore, there was a factor of 3.39 increase in the odds for going guaranteed rewards when users trusted algorithmic suggestions blindly. This psychological component exacerbates the engineering flaw because it reduces the external pressure needed to fix these systemic issues before they cause irreparable damage to data integrity. For data engineers and ML practitioners, this incident serves as a critical warning that your RAG pipelines are not set-it-and-forget-it systems. If your vector database or index is fed by public web crawls without strict provenance checks, you risk training on a polluted corpus that degrades model performance over time. You must build explicit filters for source identity, not just semantic relevance. The accuracy metric trap is real. Surface-level answer accuracy can remain stable even when source diversity has collapsed to zero. Do not rely on standard loss functions or BLU scores as your only defense against adversarial generative content. You need provenance verification layers in your architecture, such as cryptographic signatures for audio and text data that prove the origin of every piece of information before it enters the ranking loop. The trustless recommendation engine is a liability in high-stakes environments where source integrity matters. If your system prioritizes engagement and NLP relevance over trust, it will be reverse-engineered by bad actors using the same generative tools you use to build features. You must decouple ranking signals from source verification to ensure that what appears relevant is also authentic. The solution requires a fundamental shift in how we design these systems. We need multi-stage verification processes where retrieval and generation are handled separately, with strict gates for content origin before any user-facing results are served. Current gossip protocols used among autonomous agents often fail to provide the necessary guarantees of trust when faced with high-volume adversarial input. Unless we explicitly engineer for provenance as a first-class citizen in our architecture, these systems will continue to be exploited by those who understand that relevance is not the same as truth. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.